Okay, Jones Nursery specializes in custom design landscaping for residential areas. The estimated labor cost associated with a particular landscaping proposal is based on the number of plantings of trees, shrubs, and so on to be used for the project. For cost estimating purposes, managers use 2 hours of labor time for the planting of a medium-sized tree. Actual times from a sample of 10 plantings during the past month follow. With a .05 level of significance, test to see whether the mean tree planting time differs from 2 hours. Okay, differs from 2 hours. So we're talking about a two-tailed hypothesis test. We're assuming the average is 2 hours, and we're trying to see if it's not, if there is some other average. So some other average would be something less than or something greater than. So we are going to do a two-tailed hypothesis test, and we'll assume that the average is the claimed value of 2 hours. Now, the sample of 10 data points, calculating an average on that, I get 2.2 hours, and a standard deviation of 0.5164. Now, keep in mind the sample size is 10, so we're talking about a small sample. And we're using the standard deviation from that small sample. So, even more so, we need a t-distribution here. The sample standard deviation from a very small sample like that can't really be heavily relied upon to be close to sigma necessarily. So we're going to go ahead with a t-distribution. The second step is to go ahead and create the sampling distribution. In this case, it'll be a t-distribution centered at the claimed 2 hours. And we have a level of significance of 0.05, so we'll split that. So 0.025 on the upper and lower ends. And to calculate a standard error, we'll take, in this case, all we have there is the sample standard deviation, and then divide by the square root of the sample size 10. So putting that in the calculator, I get 0.1633. Now, to find the critical values, I need to go to the t-table. In this case, the area of the upper tail is 0.025, so that's the column I'll be looking at. The sample size is 10, so the degrees of freedom, remember, is to subtract 1 from that. So I'm in row 9 and in column 0.025. So I get a critical value of 2.262, and then by symmetry on the lower end I get a negative 2.262. And in step 3 I can create my rejection rule. I'm going to reject H sub 0 if my test statistic T is less than negative 2.262, or my test statistic is greater than 2.262. Okay, step 4. To calculate that test statistic, I'm going to take my sample average, 2.2, subtract my average that's been claimed, and then divide by standard deviation of the sampling distribution, or standard error of 0.1633. When I do that, I get 1.22. So that is not strong enough evidence to show that the average planting time differs from 2 hours. So I do not reject. H sub 0. We can't show that the average planting time is something other than 2 hours. Now, again, just a reminder, notice what that doesn't say. It doesn't say that the average time is 2 hours. It just says that we didn't have strong enough evidence to show it wasn't. There's a difference there, so you want to be careful. Do not reject does not mean accept. Now, the 1.22 t-value is less than the 2.26 critical value. So that basically means that my 2.2 sample average is just too close to call. It's too close to the 2 hour average as claimed by the null hypothesis. So too close to call here. The evidence isn't strong enough to get a rejection of the null hypothesis. Again, that doesn't mean that the null hypothesis is true. It's just the evidence isn't strong enough to show it's not.